to remember the 32-bit pattern, 32-bit binary pattern. So that 32-bit binary pattern is converted to decimal octet wise. So this is the example. Suppose the first octet here has a value 01110101. So if you convert this into decimal, so if you convert it into decimal, you will find out the corresponding value is 117. Okay. Next, another one, the next octet, the second octet consists of value 10010101. Now, if you convert it into decimal, you will find out the value 149. Next, 00011101. This is the bit pattern of the third octet. Now, the corresponding equivalent decimal value is 29. And the last octet consists of 000 consecutive 6 zeros are there, then 10. So the equivalent binary number is 2. So the same 32-bit pattern can be represented with the help of decimal dotted notation, that is 117.149.29.2. So it is comparatively a convenient way to remember. Okay. So this picture shows how the octets are converted into decimal dotted notation. So here is an example. Change the following IPv4 address from binary to decimal dotted notation. So this is the example, and you can do it in the reverse way too. If the decimal dotted notation is there, from that decimal dotted notation you can find out the binary notation. Okay. So here each and every value that are separated by dot. Suppose the first value is 221. So you need to convert that 221 into 8-bit binary and write that binary pattern. Next value is 34. So 34 should be converted to the corresponding binary. So this is the binary pattern of 32. Now 7 is equivalent to 5 consecutive zeros and 3 ones. So this is the corresponding bit pattern in the binary notation. So in this way we can find out the binary notation from the decimal dotted notation. Now this IPv4 address is a classful address. It is known as classful address because the total IPv4 addressing is divided into 5 different classes. Those are class A, class B, class C, class D, and class E. And each class of an address is found when given the address in binary notation or in decimal dotted notation. So by inspecting the address, we can identify the address falls in which class, whether it is a class A address or whether it is a class C address, etc. If the address is given in binary notation, the first few bits can immediately tell us the class of the address. So by inspecting the first few bits, we will determine the class of that address. Okay, but if the IP address is given in decimal dotted notation, then we need to inspect the first byte and we need to convert the first byte data to corresponding decimal value and check whether the decimal, in which range the decimal value is reading. Then from that we can find out the class of that IP address. So these are the examples. Okay. If the IP address is in class A, that will determine in the binary dotted notation where the first bit of the first byte should be 0 always. For class B, first two bits of first byte should be 1 and 0 always. For class C, first 3 bits of first byte should be 1 1 0 always. For class D, first 4 bits of the first byte should be 1 1 1 0 always. And for class E, first 4 bytes, sorry, first 4 bits of first byte should be 1111 always. Okay. Now we will see gradually that what is the range of class A address. Class A address range is from 0 to 127. Class B address range from 128 to 191. Class C is from 192 to 223. And class D is from 224 to 239, and class E is from 240 to 255. Okay, so we will see gradually how this calculation can be done. And normally, class A, B, and C are commonly used for unicast communication in the network. Class E address is never used because it is reserved for future utilization, and class D address is used for different purpose. It is basically used for broadcast address. So now we will now we will discuss detail the class A address. Class A address is divided. Just a minute, please wait. Okay, we know that we have a 32-bit address, and those 32-bit address is divided into 4 blocks or 4 groups. Okay, now in each group there are 8 bits, hence it is comprised with 4 bytes. So in class A address, 1 byte is used to identify network. So it is commonly known as net ID. Just 24 bits are used to identify any host within that network. Okay, so from this we can easily identify the range of class A. Okay, so in class A address is divided into 128 different blocks. Why 128? Why it is not 256? Because the first byte is used to identify net ID, and in the first byte we have 8 bits. So with 8 bits we should have identify 2 to the power 8 or 256 different networks. But it is not. We can't identify 256 different networks because you can see in the class A address, the first bit of the first byte will be always 0. So we can't use that bit. That's why the class A address is divided based on the rest 7 bits of the first byte. So with that 7 bits, we can identify 2 to the power 7 or 128 different networks. Okay, and in those 128 different networks, in each network we can have 2 to the power 24 different hosts. So can you imagine the number of hosts that can be accommodated per network? It is huge, 2 to the power 24. So in real life world, no organization is present that have the number of clients of 2 to the power 24. It is huge. No such organization is available, no such organization is present in the present world in real life that has 2 to the power 24 nodes. So lots of class A addresses were wasted. Okay. Now what is the range of class A address? The range of class A address is starting from 0000. Why 0000? If the first bit is 0 always, it is fixed. So after this bit, we still have 31 locations. So if we fill the all 31 locations with all zeros, then we will find the starting address of A. Okay. The net ID is identified with red color octet, red color value, and host ID is identified with blue color value. So this is the starting address of class A, that is 0. If we fill the the rest 7 bits of the first byte with all 0, we get 0. Then all the other groups or bytes, the second byte, third byte, and fourth byte will be filled up with all zeros. Then we will find this starting address. Then what is the ending address of class A? We cannot change the first bit, that is fixed, that should be 0 always. So rest 31, if the rest 31 bits of class A address are all 1, then what should be the value of the octets? Here, first 0, then consecutive 7 ones are there. So anyone convert this into corresponding decimal value and tell me what is the value. 0 and consecutive 7 ones. কত হচ্ছে? কত হচ্ছে ভ্যালু? Only for first byte.
0
কি করে 0? 0 তারপরে 7টা 1 তো।
হ্যাঁ
আর তার করেসপন্ডিং ডেসিমাল ভ্যালু কত হচ্ছে?
স্যার 127 কি?
127. Yes, it's 127.
yes sir 1
ওকে, আর বাকি কটা বিট পড়ে রইল তাহলে? 24 বিটস in 3 different octets. So these 24 bits will be filled up with all ones. That is the highest value of class A address. তাহলে এবার বাকি যে second byte, third byte, fourth byte, if it fills with all ones, then we will get value 255. এটা করে রাখো। consecutive 8টা 1, তার corresponding decimal value কত হবে? It should be 255. দেখো তাই হচ্ছে তো?
আচ্ছা 127 plus 128 255.
127, yes, 255. So this is the last address of class A. তাহলে ফার্স্ট অ্যাড্রেস কি করে বার করব? আমি 32 খানায় শূন্য বসিয়ে দেব। তাহলে 32 খানায় শূন্য বসালে অক্টেট গুলো কি হবে? 0.0.0.0। আর লাস্ট অ্যাড্রেস কি করে পাবো? ফার্স্ট বিটটা আমি 1 বসাতে পারছি না, কারণ ফার্স্ট বিট ইজ ডিফল্ট, বাই ডিফল্ট ভ্যালু শুড বি 0। তাহলে বাকি 31 খানা যে লোকেশন পড়ে থাকছে, সেই 31 খানা লোকেশন আমি ফিল আপ করে দেবো অল 1 দিয়ে। তাই যদি করে দিই তাহলে ফার্স্ট octet value will be 127, that is shown with red color. Then the next 3 octet value will be 255 each. So this is the last value of the class A address, 127.25, sorry, 255.255.255. So the class A address range is from 0.0.0.0 to 127.255.255.255. Okay. Now, within this class A address range, there is a special address that is called loopback address. The address is 127.0.0.1. Okay. That loopback sorry. That loopback address is used for different purposes. This loopback address is not used to identify a particular host in a network. This loopback address is used for maintenance and checking purpose. Okay. So when you attach your LAN card in your system, then for troubleshooting purpose or for maintenance purpose, we will use this loopback address. Okay. So just after attaching your LAN card in your machine, and after installing the device driver of the corresponding LAN card, if you give this command in command prompt, ping, এখানে লিখলে কি বুঝতে পারবে তোমরা? ping PING space 127 dot 0 dot 0 dot 1. Okay. Okay. I am showing you my with my system. Can you see the screen? Black screen. Can you see this
Yes,
black
sir.
screen? Now I am giving this command ping 127.0.0.1. Okay. Then I am pressing enter. So this is the output from the machine. Okay. Normally in Windows, 32 bytes of data is transmitted, and that 32 bytes of data is received by my LAN card. Okay, and if you give this command only ping 127.0.0.1, then it will send only 4 packets, and it will try to capture that 4 packets. That means your LAN card, these 4 packets, some packets will some packets will be transmitted from your LAN card, the transmission line from your LAN card, and the same packet is received by your LAN card through the receiving line, and then it will judge the time difference. You will calculate the time difference. But always you will get the time difference is less than 1 millisecond, and at last it will give the summary. 4 packets are sent, 4 packets received, so 0% packet loss. Okay, so minimum approximate round trip times or round trip delay, যেটা তোমাদের বলেছিলাম এর আগে, রাউন্ড ট্রিপ ডিলে মানে প্যাকেটটা যখন ট্রান্সমিট হচ্ছে, ঠিক যে মুহূর্তে ট্রান্সমিট হচ্ছে সেই সময় টাইম কাউন্ট উইল স্টার্ট, and when the packet is received or the acknowledgement is received, the time count ends, and the system will calculate the time difference between the packet or acknowledgement received and the packet sent. So here the minimum round trip time is 0 millisecond, maximum round trip time is 1 millisecond, the average round trip time is 0 millisecond. Okay, but if I want to ping some other devices, suppose my system is connected to the internet, so I'm trying to ping Yahoo server. Okay, I don't know the exact IP address of the Yahoo server. So instead of giving IP address, I will give its domain name, yahoo.com. Then what will happen? Our ISP, there is a DNS server. So that DNS server will maintain a mapping table, the DNS table. So from the DNS table, the IP address of yahoo.com will be retrieved, and ultimately the ping command is executed on that IP address, and it will provide a result. Just see the difference of the result. Okay, so this is the difference. Here we have ping 127.0.0.1. This is the static IP address, that is called loopback address. So it is getting reply from this. So when we are ping Yahoo server, my closest Yahoo server IP address is 202.165.107.50, and I really don't know that IP address, that particular IP address. Okay, that's why I ping the domain, and the DNS server of my ISP will map the domain name with the corresponding IP address based on the DNS table maintained at the DNS server, and it gathered acknowledgement or reply from that Yahoo server. What is the name of that Yahoo server? The computer name of that Yahoo machine is new-fp-shed.wg1.b.yahoo.com. That is the computer name from where the reply is coming for this ping command. Okay, and always the 30 in Windows, always the 32-bit data is sent, and in case of Linux, or the 64-bit ICMP packet is sent. Okay. Now this is the time. This is the time difference based on which the acknowledgement is received from Yahoo server. As the line is steady, that's why I got a steady response. Always it is 63 milliseconds for all four packets. That proves my internet line is quite steady. It is not fluctuating. Okay, and the TTL value is 50. Now compare the TTL value. When I am pinging my own machine with the loopback address, my TTL value is 128. And when I am pinging Yahoo server, the TTL value changes to 50. So what is that TTL value? The full form of the TTL value is actually time to live, but it doesn't have any relation with real time. Actually, it has a relation with hop count. Okay, so when you send your data, when you send your information to network, always your information or your data packet will cross some junction point, and specifically routers are the junction point. So when your data packet crosses one router, your TTL value is decremented by 1. So your TTL value is filled up with highest value, that is 128. When it crosses one junction point, then the TTL value is decremented by 1. So it will be 127. Okay. So from this we can we can calculate that how many hops or how many junctions are there between your machine and between Yahoo server. Okay. As for the first one, as there is no junction point when we are pinging our own machine with the loopback address, there is no junction point. That is, no router is involved in the communication. So your LAN card is transmitting a packet, and your LAN card is receiving the acknowledgement of the packet. So there is no question of other junction points to be involved in this communication. That's why the TTL value is 128. But when we are sending data packet to Yahoo server, it has to be crosses some junction point. It has to be crosses some router. So how many routers it has crossed? Just subtract the value 50 from 128. What will be the value? Value will be 78. That means there are 78 junction points between my machine and Yahoo server. Okay, so when I send ping korchi mane ki, basically we are sending a packet to that server. Okay, so when we are sending that packet has to be crossed 78 routers or 78 junction points. After crossing 78 routers or 78 junction points, my transmitted data is received by Yahoo server, and the Yahoo server is giving the reply. Okay, so my machine will calculate the time difference between the transmitted data and receiving acknowledgement. That time difference is basically the 63 milliseconds. Now, if I ping Google server, we will get different output. Okay, this is the output from Google server. So now, what is the IP address of Google server? The nearest IP address is 142.250.195.196. Now, and what is the time duration between the transmitting packet and receiving the acknowledgement? That is 31 milliseconds for the first packet, and then 30 milliseconds for the rest of the packets. Okay, so minimum time is 30 milliseconds, the maximum time is 31 milliseconds, the average time is near about 30 milliseconds. It actually it should be about 30.25 milliseconds. And what is the TTL value? It is 115. So from here, you can easily calculate how many junction points the data packet has been crossed. কত junction point or কত hop count cross করেছে গুগলের ক্ষেত্রে? Anyone?
13.
13. Exactly. So just subtract the value 115 from the highest value 128. So you will get 13. So that means after crossing 13 routers or 13 junction points, my data packet has reached to the Google server. Okay. So this is the utility of the loopback address. And loopback address has another significant usage, that when you attach your LAN card to your machine, you can check whether your LAN card is working properly or not before connecting your machine to real network. If your LAN card is connected, working well and connected successfully to the ports, then your LAN card will provide the correct output, that is reply from 127.0.0.1, the data packet is equal to 32 bytes, the time should be less than equal to 1 millisecond. This type of output it will show when you ping your own machine.
স্যার এখানে জিরো ব্যাপারটা আরেকবার বলুন, যে এটা কেন প্রথমেই 255টা হচ্ছে না প্রত্যেকটার মতো?
না, তোমাদের এখানে রেঞ্জ বার করতে হবে, ঠিক আছে? তো ফার্স্ট বাইটের রেঞ্জ কত হতে পারে? ফার্স্ট বাইটের লোয়েস্ট রেঞ্জ কত হতে পারে বলো?
0।
কটা জিরো? কটা জিরো?
আমার পুরো 8টা বাইটই 0 হবে।
8টা বাইটই জিরো, সেই জন্য আমি এখানে সব জিরো পেয়েছি।
হ্যাঁ,
8টা বাইটই জিরো মানে সেটা করেসপন্ডিং জিরো।
হুম
আর বাকি বিটগুলোর ভ্যালু কত হবে? যদি লোয়েস্ট ভ্যালু হয় তাহলে এগুলো সব জিরো।
হুম
তাহলে এই সেকেন্ড বাইটের জন্য এই জিরোটা পেয়েছি, থার্ড বাইটের জন্য এই জিরোটা পেয়েছি, ফোর্থ বাইটের জন্য এই জিরোটা পেয়েছি। এটা হচ্ছে লোয়েস্ট অ্যাড্রেস অফ ক্লাস এ, ঠিক আছে?
হ্যাঁ, মানে কিন্তু আমি জিজ্ঞেস হচ্ছে ওটা 255 প্রথমটা কেন হচ্ছে না, মানে প্রথমটা ক্ষেত্রে প্রথম বিটটা কেন 0 হচ্ছে?
প্রথম দিকটা জিরো হচ্ছে এই যে এখানে যে বলা হয়েছে হাউ টু আইডেন্টিফাই। এটা যদি জিরো না হতো, এরকম যদি পার্টিকুলার কোনো তুমি একটা পার্টিকুলার কোনো রুল না রাখতে, তাহলে তুমি কিভাবে আইডেন্টিফাই করতে যে কোনটা ক্লাস এ অ্যাড্রেস, কোনটা ক্লাস বি, কোনটা ক্লাস সি, কোনটা ক্লাস বি? তোমাদের একটা রুল রাখতে হবে, একটা লজিক রাখতে হবে আইডেন্টিফিকেশনের জন্য, নাহলে সব মিক্স আপ হয়ে যাবে একসাথে।
ওকে স্যার,
যখনই তুমি পাচ্ছ যে ফার্স্ট বিট ভ্যালুটা জিরো, তার মানে তুমি চোখ বুঝে বলে দাও যে এটা ক্লাস এ অ্যাড্রেস। আর এটাকে যখন তুমি ডেসিবেল ডটেড নোটেশনে বলছো, তখন দেখো ফার্স্ট বিটটা জিরো বলে এটা কখনোই 128 এ পৌঁছতে পারবে না, পারবে না তো?
না স্যার।
হ্যাঁ, তার মানে তোমার অ্যাড্রেসের রেঞ্জটা ডেসিবেল ডটেড নোটেশনে যদি লেস দ্যান ইকুয়াল টু 127 হয়, তাহলে শুধু ফার্স্ট বাইটটা তুমি ইন্সপেক্ট করেই তুমি বলে দিতে পারবে যে এটা ক্লাস এ অ্যাড্রেস। অন্য বাইটগুলো আর দেখার দরকারই নেই তোমার। অ্যাকচুয়ালি ওইভাবেই আমরা ওটাকে বার করি।
ওকে স্যার।
ঠিক এরকম ভাবে ক্লাস বি, সি, ডি, ই এইগুলো আমরা বার করব। ওকে, তাহলে এই হচ্ছে ক্লাস এ অ্যাড্রেস। নেক্সট উই উইল ডিসকাস দ্য ক্লাস B address. In class B address, as we have seen, that lots of class A addresses were wasted because class A addresses there is a limited number of network, but in each network there can be a huge number of hosts, and that many number of hosts is not required for any individual network. এরকম কোনো নেটওয়ার্ক পৃথিবীতে পাবে না যে নেটওয়ার্কে 2 to the power 24 খানা নোড থাকে। ইট ইজ হিউজ। ওকে, 2 to the power 10 মানেই হচ্ছে কত? 1024। এবারে তুমি যদি দুই দিয়ে গুণ করতে করতে যাও, তাহলে দেখবে যে 2 to the power 24 এর ভ্যালুটা কত দাঁড়ায়। নিজের একবার করেও দেখতে পারো। That's why lots of class A addresses were wasted. That's why the scientist has designed a different class of address, that is class B address. In class B address, another byte or another octet is allotted to identify network, so that the number of network will be increased and host per network will decrease. So here, as 2 bytes are allotted to the net ID to identify different type of networks. So 2 bytes মানে কত? 8 plus 8 16. Okay, and 2 to the power 16 is equal to কত? 2 to the power 16 means 16,384. So in class B address, total 16,384 blocks are there. Okay, with different net ID. And in each block there will be 2 to the power 16 different ports. Because these two, এই ছবিটা একটুখানি ভুল আছে, পরেরটা তো পরেরটা তো ভুল। ঠিক আছে, এই ছবিগুলো আমি তোমাদের তো বোধহয় গুগল ক্লাসরুম এটা এখনো দিইনি না, গুগল ক্লাসরুমে বোধহয় এটা এখনো দেওয়া হয়নি। এই ছবিগুলো অ্যাকচুয়ালি ভুল আছে, এই ছবিগুলো আমি কারেক্ট করে গুগল ক্লাসরুমে একবারে দিয়ে দেবো। এইখানে এই এই সবুজ মার্কটা হবে না, এই সবুজ মার্কটা সাদা হবে, এই দুটো সবুজ হবে। কারণ সবুজ মার্ক দিয়ে আমরা আইডেন্টিফাই করছি হোস্ট আইডি, আর সাদা দিয়ে আমরা করছি নেট আইডি। So in class B, actually first 2 bytes are allocated to identify the network. Okay. So what will be the range of class B address? The range is between 128.0.0.0 to 191.255.255.255. Okay. And out of that, 16 blocks or 16 different network ID is reserved for private addresses. But here also lots of class B addresses were wasted, because class B address says there will be 16,384 different networks, and in each network there will be 16,384 different nodes, and that amount of node is also huge for any network. Very few companies, very few organizations are there, are available or are there at present in the real world, which requires near about 16,000 nodes in each network. Very few companies are there. So for those few companies, it is not very wise decision to allocate as many as number of nodes per network. That's why we have to shift to class C address. So before going to class C address, I will discuss how the range of class C address is defined. Look, from this you can see the class B address, first 2 bits of class B address should be 10, that is fixed. So now tell me, what should be the lowest value of class B address? The first 2 bits are 10, that is fixed. So next 30 bits are filled up with, if the next 30 bits are filled up with all zeros, then that will be the lowest value or the lowest address of class B. Right? তাহলে সেটা যদি হয়, তাহলে ক্লাস বি অ্যাড্রেসটা স্টার্টিং অ্যাড্রেসটা কত হচ্ছে? For first byte 1 is there at the first location, at MSB location. Next they are all zeros. Well, it is equivalent to 128. Next, the second byte is filled up with all zeros, so it is equivalent to 0. So these two, 128.0, comprises the net ID, and the rest of the portion, that is the third byte and fourth byte, those are also filled up with all zeros. That actually represents the host ID. Okay, so these two zeros are represented with green color. So this is the lowest address of class B. Now, what should be the highest address of class B? Highest address can be found by putting all these 30 locations, by putting value 1 in all these 32 locations, all these 30 locations. Because the first 2 locations are fixed, has fixed value 10. It cannot change these values, because these 2 values will quickly identify the class B address. So the rest 32 bits, if the rest 30 bits are filled up with all ones, then what is the value we will get? Let's calculate. For first byte 10, then 6 ones are there. কত হচ্ছে ভ্যালুটা দেখে নাও। যদি all 8 ones হয়, তাহলে আমরা হাইয়েস্ট ভ্যালু পাচ্ছি 255, আর সেখান থেকে যদি এই পজিশনের ভ্যালুটা যদি 0 হয়ে যায়, তাহলে আমার মাইনাস হয়ে যাচ্ছে 64। তাহলে 255 থেকে 64 বাদ দিলে দেখো কত আসছে 191. That's why the first bit value is 191. And the rest all octaves are filled up with all ones. Highest value যদি ধরতে হয় binary. So all ones means it is actually 255 or 255 or 255. Clear? Class B addresses, class B addresses highest value or lowest value. Hello?
Yes, sir.
Yes, sir.
তাহলে আমি ক্লাস সি তে যাচ্ছি। কেন ক্লাস সি তে যাচ্ছি? বিকজ হিয়ার অলসো lots of class B addresses are wasted because there are very few organizations those require that amount of nodes in a particular network. So in class C address, 3 bytes or first 3 octets are allocated for net ID, and only the last octet is allocated for host ID. So there will be 2 to the power 24, that is 2 lakh 9,000, 20 lakh 97,152 different networks in there in class C address. And in each network there will be 2 to the power 8 different hosts. Okay, তার মানে নিয়ার অ্যাবাউট 20 লাখের উপর, প্রায় 21 লাখের কাছাকাছি আমার ডিফারেন্ট নেটওয়ার্ক হতে পারে। আর এক একটা নেটওয়ার্কে আমার 2 টু দি পাওয়ার 8, তাহলে 2 টু দি পাওয়ার 8 মানে কত? 256, তাহলে 256টা করে মেশিন হতে পারে আর 256টা করে নোড হতে পারে। So this amount 256 nodes in each network, that is quite reasonable. There are lots of organizations that require 255 or 256 or more than 250 or more than 200 nodes in one network. Okay, if we look for any university or any engineering colleges, is having more than 150 machines in one network, or some engineering colleges may require near about 200 or near about 250 machines in each network. So this amount, 256 number of nodes in each network, that amount is quite reasonable. But if any organization requires more than 256 nodes, then what that organization will do? That organization should use 2 different networks. Okay, so more than 256 machines cannot be accommodated in one network. So in that case, that network will use 2 adjacent network or 2 different network address to accommodate all the nodes. Okay, কারণ এক একটা নোডে 256 এর বেশি, এক একটা নেটওয়ার্কে 256 এর বেশি নোড তুমি অ্যাকোমোডেট করতে পারছো না। এবারে তোমার এরকম হতেই পারে, ধরো বেশ বড় বড় কলেজ যেগুলো, ধরো বা বড় বড় ইউনিভার্সিটি যেগুলো, সেগুলোতে দেখা গেছে যে ধরো 400-500 করে মেশিন রয়েছে। তাহলে 400-500 মেশিন একটা নেটওয়ার্কে কি করে থাকবে? সম্ভব না। ম্যাক্সিমাম 256টা থাকতে পারে। তাহলে সে দুটো নেটওয়ার্ক ইউজ করছে বা 3টে নেটওয়ার্ক ইউজ করছে। ধরো কারো 550 মেশিন রয়েছে, তাহলে একটা নেটওয়ার্কে 200টা, আরেকটা নেটওয়ার্কে 200টা, আরেকটা নেটওয়ার্কে 150টা মেশিন ইউজ করছে, নো প্রবলেম। So if any organization requires more number of nodes in the network, then some more network ID can be allocated to that organization. Okay. So here the 256 blocks are used for private addressing. So class A addresses are designed for small organization to medium organization, and if any organization needs to attach more hosts, it can acquire more network or more blocks. Okay. And now we will calculate what is the minimum and maximum address range of the class C network. Class C network address range কি হবে? The first 3 bits should be 110 always. Should be 110. Okay. So what should be the minimum address of class A? The first 3 values are 110, that is bit. Rest 29 bits are filled up with all zeros. If we fill that with all zeros, then what is the value we will get? We will get value 192 for the first octet, and then value 0, 0 and 0 for the last 3 octets. So this will be the lowest value or lowest address of class C. And what should be the highest value of class C? The first 3 values are 110 and rest 29 bits are filled up with all ones. So all ones will be filled kori. So first, second, third and fourth octet will return the value 255 and first octet will return value 223. তাহলে 226 করে পাচ্ছি। তাহলে যদি সবকটা 1 হয়ে যেত, অল 8 1 যদি হয়ে যেত, তাহলে তার হাইয়েস্ট ভ্যালু হতো 255 আর সেখানে এই পজিশনের ভ্যালুটা হচ্ছে 0। তাহলে দিস পজিশন ইজ রিলেটেড টু 2 to the power 5 or 32। তাহলে ওখান থেকে 32 যদি বাদ দাও, 255 থেকে যদি 32 বাদ দাও, তাহলে কত পড়ে থাকে? 223। So this 223 is here in the first part or first part. So in this way, class C address is calculated. Next, class D address. Class D address is used for multicast addressing within a network. Okay, broadcast or multicast addressing. Multicast means it is one type of broadcast. Okay, so there are 3 types of casting. One is called unicasting, another is called broadcasting, and the third one is called multicasting. Unicasting means always one-to-one communication. Broadcasting means one-to-many communication. But multicasting means one-to-many communication, but it is not meant for all. Communication will be established between one to a group of entity or a group of device. What is the that's why class D address is not divided into different net ID and host ID. The address range of class D is from 224.0.0.0 to 239.255.255.251, and it is also calculated in the same way. তাহলে class D এর lowest address যখন হবে তখন কি করব? First 4 bits are has fixed value 1110. Then the rest 28 bits are filled up with all zeros. So you will get 224.0.0.0. Our highest address কি করে পাবো? First 4 bits are of all of 110 and rest 24 bits are filled up with all ones. Okay, so you can teach what you. All 8 bits are, if all 8 bits are filled up with all ones, you will get 255. So there are 3 255 numbers, and for the first byte, the value will be calculated 255 minus 16. This is equivalent to 16. Okay, so 255 minus 16, that is 239. So that is the last address of class D. Next, class E address. Class E addresses were designed for future use. It is reserved. It is not reserved address. So how to define the class A address or class E address? The first 4 bits of the first byte are of all ones. Okay. So like class D, class E address is also not divided into different net ID and different host ID. The address range of class E address is 240.0.0.0 to 255.255.255. So how can we calculate this one? First 4 bits are of all ones. Then if you fill the rest 28 bits with all zeros, you will get this value 240.0.0.0. And if all the values are filled up with all ones, তাহলে কত হবে? এখানেও 255, 255, 255, 255. So this is about class E address. Now there are some solutions. Find the class of each address. How can you find out the class of each address? This is a class A address. Why this is class A address? So if you inspect the first bit of your first byte, it is 0. That means it is a class A. Okay. Now, what question number B? this is a class C address. Why this is a class C address? The first 3-bit patterns of the first byte are 110. If the bit pattern is starting with 110, that means it is a class C address. Now, question C. It is the class A address again because the first byte value is 14 and that is within the range of 0 to 127. That means it is the class A address. And number D, it is the class E address because the first byte value is 252. So anything beyond 240 is is the example of class E address. Okay. Now, how you can find out the error, if any, in the following IP addresses? What is the error in first question? The error is due to this zero, due to this leading zero in the third octet. Okay, there must not be no leading zero. Uh, what is the problem with this question? Question number B. There are 4 dots instead 3. That means 4 dot actually differentiate 5 octets, and there cannot be more than 4 octet or cannot be 4 numbers according to decimal dotted notation for IP address. That's why it is wrong. Then for question C, why it is wrong? Because of the value written for the third octet. The value is 300. No octet value will cross the limit 255 because এক একটা অক্টেটের জন্য 8 বিট করে রাখা হয়েছে। 8 বিটের সবটাই যদি 1 হয়ে যায়, 8খানাই যদি 1 হয়ে যায়, তাহলে ম্যাক্সিমাম ভ্যালু হয় 255. It crosses that limit. Now, what is problem with question number D? The IP address is shown with a mixture of binary and decimal dotted notation. You cannot define the IP address in that format. Either you have to fully represent it in decimal dotted notation or totally in binary notation. The mixture mode cannot be accepted. Okay. Now this is the summary of the number of blocks of each of the classes and number of hosts in each class. Okay. So this is the end of today's discussion. Now first give your attendance. Vikas Kumar Jadhav. Vikas Kumar Jadhav is present. No. Sapodipto present. Shapnonil Panda absent. Shubhodip present. Shubhodip. Supradeep present. Sumedha absent. Sudhir Jadhav present. Suchita Pal present. Subhashish present. Souvik Mondol present. Souvik Maitri present. Soumya Chatterjee. Soumya absent. Somdatta present. Seoshi. Seoshi present. Sayantika present. Sayantan. Yes. Sayantan present. Saket Kumar Aman. Saket ছিল তো একটু আগে। Saket present. Saheb. Saheb absent. Rohit Jha absent. Rohan Ghosh present. Rajdeep present. Sorry. Leshmi Kumari absent. Rajdeep present. Rajvidan absent. Rajagaji absent. Pravish present. Porivesh present. Nitish absent. Joy absent. Harsh absent. Dona present. Right? Dona present. Dipha present. Devargo present. Vishal
Present, sir.
Singh. Vishal Das. Ayonesh absent. Asif Ali Ansari absent. Arup present.
Yes, sir.
Anish absent. Aman present. Alok Tiwari absent. Ahmed Asafi absent. Diganko মৃগাঙ্ক ছিল না? মৃগাঙ্ক ছিল? মনে করছি না। রাহুল রায় প্রেজেন্ট, ইরফান অ্যাবসেন্ট, কিরণময় প্রেজেন্ট, প্রীতি রুজ প্রেজেন্ট, আরাফাত অ্যাবসেন্ট, অরিত্র, অরিত্র অ্যাবসেন্ট, মহাকার অ্যাবসেন্ট, সুমন প্রধান, সুজিত মাইতি অ্যাবসেন্ট, মিঠুন অ্যাবসেন্ট, বিমল প্রধান অ্যাবসেন্ট, সুমন দাস অ্যাবসেন্ট, উৎপল মাইতি প্রেজেন্ট, সুমন কল্যাণ দাস অ্যাবসেন্ট, সৌমেন ঘড়াই, সৌমেন প্রেজেন্ট, বিশ্বলয় অ্যাবসেন্ট, অভিজিৎ অ্যাবসেন্ট, সায়ন অ্যাবসেন্ট, সুচিত্রা প্রেজেন্ট, সন্দীপা অ্যাবসেন্ট, মানব অ্যাবসেন্ট। হ্যাঁ, হ্যাঁ, কারোর কিছু বাকি আছে ইয়ে প্রেজেন্ট দিয়ে দেখাও, অ্যাটেন্ডেন্স দেওয়ার? ঠিক আছে, ঠিক আছে, লিভ করতে পারো। কোনো কোশ্চেন থাকলে পরের দিন জিজ্ঞেস করে নিও। আজকে